Okay, this is the introduction for lab number 18 on buoyancy, and we know Archimedes' principle of buoyancy says that when you take an object and you dunk it under some water, that it's going to experience a buoyant force upwards, and that buoyant force is going to be equal to the weight of the water that is displaced. So what we can kind of do is we can say, well, I know that the buoyant force is going to be equal to the weight of the fluid that is being displaced. So we're going to open up this simulation right over here, and we're essentially going to take a bottle of water, or we're going to take a bottle and we're going to dunk it in water, and we're going to measure its weight in air, and we're going to measure its apparent weight in water, and realize that the buoyant force is the difference between them. So first record the mass and volume of the bottle, they're on the screen. Convert the mass to kilograms, just simply dividing by 1,000. And then what we're going to do is we're going to go ahead and measure the weight, or calculate the weight of the bottle. We know that the weight of the bottle should be equal to the mass multiplied by gravity. Again, one of the most important things that you'll learn in Physics 1.1. So then we're going to go ahead and click Start, and what we're going to observe is we're going to have a bottle, and it's going to have some weight acting in the downwards direction. And initially that weight is supported by the force probe. So the force probe is actually measuring the weight of the object in air. Then what happens is we dunk it in water, and we're going to get a buoyant force, just like that. What that translates to is this weight that we're measuring right now is no longer the weight, it's going to be something called the apparent weight. The difference between the weight and the apparent weight is going to be the buoyant force. So you're just going to subtract this number and this number. Then what we're going to do is we're going to say, well, the buoyant force should also be equal to the weight of water that is displaced. So I have a couple of questions here. And then what we're going to do is we're going to say, well, if we go ahead and we took that bottle and we stuck it in the water, it's going to displace a weight of liquid that's equal to a volume of liquid equal to the volume of the water. And what we can do is we can say, well, we know that density is equal to mass divided by volume, so we could figure out the mass of water that is displaced knowing the density, and we can go ahead and convert that to kilograms. Then we can say, well, what is the weight of the water that was displaced? Well, that's going to be equal to the mass of the water that was displaced multiplied by gravity, and just compare that to the buoyant force. They should be pretty darn close. So let's pop over to the simulation real quick and we'll take a look at it. So you're going to pop it open, you can see this guy, and we see the mass of the bottle and the volume of the bottle. Remember that 1 milliliter is also a cubic centimeter. We're going to click Start, and you're going to see the guy dunk it in there. And if you scroll on down right over here to the bottom, you can kind of see that this was its weight, should be close to what you calculated, and this is its apparent weight. Just go ahead and read that number right off there and put it in your lab. Now once you're done with that part of the lab, we're actually going to think about what makes things float or sink a little bit. So we're going to go back to our good friend Sim Bucket, and we're going to turn the fluid to water, and we're going to take a look at two objects, a gold one and a foam one. The gold one's probably going to sink, the foam one's probably going to float. And what I have you do is I just have you measure the mass of each of them, and I also have you measure the volume of each of them. And then I actually do have you convert it into cubic meter, so volume and volume. Then what we can do is we can just go ahead and straight up calculate the buoyant force of each one of these two guys. And again, what we're going to do is we're going to say that the buoyant force is going to be equal to the density of the fluid multiplied by the volume that was submerged, as well as gravity. So you're going to record the buoyant force of each of them, and then you're going to calculate the weight of each of them. Remember, weight is mass multiplied by gravity. And then kind of using these two numbers right here and right here, talk about why the foam floats and why the gold sinks. So let's pop over to our good friend Sim Bucket, and what we're going to do is we're going to have the gold, and we can measure the mass just like we did before. We can dunk it under there, take the difference, and measure the volume just like we did before. And we do the same thing for the foam object, measure the mass, measure the mass, measure the volume, and again you have to hold it under there, and from that point you should be good to go.